So in this lecture we'll discuss the generation via artificial neural networks. We'll discuss generation of images and also videos. I'll focus more on the application side, so like no papers, no formulas, no architectures, only like the thing that you will be able to use right now on your current projects. So what will be discussed? Where generative computer vision can be used, what models and interfaces you can use, how to control the generation. It can be controlled textually or visually. And also, what are the capabilities of generating video right now, and general tips for generation. So a little bit about me. I did a few projects. I was a co-founder and CTO of one startup which was focusing on generating celebrities, and we were paying royalties for celebrities. I was also doing some real-time object detection projects, also did some projects in entertainment industry and in the financial sector. More info you can have a look at my website. So let's focus right now on the current state of the development of AI. So the AI is here and is fully fooling us. On the left side you can see some fakes from Facebook, and there are even some articles. There is written, old people are praying to an AI shrink geniuses on Facebook. So like the most basic generations, even they can fool us. And on the right side are one of the most popular fakes of the AI sector. Here you can see Pope in Balenciaga and also the burning Eiffel Tower. All those pictures are not real, all those pictures are fake. Where generative content can be used. So, like, I do find two niches which are very interesting. The first niche is advertisement. It can really be used in advertisement industry to generating images of celebrities. Because, like, to have a correct photo shoot of a celebrity, it is just really hard. You need the producers, you need the photographers, lighting directors, makeup artists, assistants, and also you should spend a lot of time on post-production. But like, and even star will give you some problems. She will ask money for a second on the stage, and also maybe the star is not okay of doing some things, for example, like riding on a tiger, like, or something, or doing something like that. And the second industry I would love to mention is the sexual industry. Here are two examples. The left one is AI OnlyFans model, and it's very interesting because AI OnlyFans model can have even revenue even bigger than the natural OnlyFans models. And not only that, they also can. It's much easier to create artificially the ideals of a human body type than like genetically. And the second example is there are some AI girlfriends, so it's basically an LLM chat, so you're chatting with some person there, and they have an amazing feature that it is possible to generate an image based on a context. So you're chatting and like he or she is writing to you, I'm in the bathroom, so you can write like, send me a photo, and it will generate you a photo of this AI model in the bathroom. By the way, I know real guys who are spending $10K of dollars chatting with AI girlfriends. So like, the industry is here, the industry is real. Let's discuss architectures. I promised without like a lot of various sophisticated words. So like, there are a lot of architectures, but one is mainstream right now. This architecture is diffusional models. I won't mention how they're working, but just keep in mind. So, the process of diffusional models, they are able to create realistic and well-grained images. But like, they also have some cons. What about the cons? The first cons is that the generation of one image takes much longer time. So it's, you would need a lot of hard optimizations if you want to generate it like real-time way, etc. Also, there is a problem with maintaining the consistency of a character. If you want to generate some character and it should be 100% consistent in all of the images, it's a problem. It's solvable, but like it's much harder than in other architectures. And the last thing is harder to interpolate across the Latin space. It sounds very difficult. Let me explain. So, for example, I have generated a beautiful boy with blonde hairs, and I want to make only one change. I want to change the hairs of a boy from white hairs to the red hairs. And I just, for example, just changed the prompt. I wrote like boy with blonde hairs. Now I changed the blonde to red hairs. And what I see, it doesn't generate the same boy but with the red hairs. It generates completely the different image. So because of the internal algorithms, like maintaining, interpolating through the lattice space, like interpolating through the instruction space is very hard. It will give you different images on all changes. So there are two types of models: the closed source models and open source models. You all know the closed source models like DALL-E 3 for in the ChatGPT or Midjourney, which you can use in a Discord, etc. They have an amazing friendly interface, and if you are just a newbie and you want to type something, you just type it and you will have amazing results. The problem is that you don't have access to internals, so you cannot tweak the parameters of the model to generate more sophisticated image. And here comes the open source. Of course, it is harder to set up. You need your own server, you need to download all this stuff, and then you open some random interface and want to generate an image. And then usually it could not even work. But like, and then you generate an image, and it's not as beautiful as in closed source options. But like, because of the ability that you can tweak all the parameters, because of the ability that you can fine-tune the model, the open source wins. So like for all more sophisticated pipelines, like the only way is open source. The open source, there's Stable Diffusion, there's Kandinsky, there's a lot of different models. I do recommend just use the Stable Diffusion as a mainstream. Okay, so like how can you manipulate the image generation? There is a lot of textual and other settings. So you can write the positive prompt, what text should the image resemble, the negative prompt, what should the image resemble the least. But like the most important thing here is that there is a lot of settings, there's a lot of different settings, but all those settings, they are a trade-off. You cannot have an ideal setting which will generate always the thing that you really need. As an example, as one of the most important trade-off is a text guidance trade-off versus image quality trade-off. So if you want the image to resemble the text guidance the most, then like the quality of the image would not be the best, and vice versa. One more trade-off I would say is the quality of the image and the training time, like the inference time of a model. Also, there is not only the textual guidance, there is also visual guidance. I will mention three types of this visual guidance. So like the first one is as the edit. For example, we have an image of a girl and we want some hairs of it to be yellow. So what do? We open paint and with a yellow brush just paint yellow stroke. Then we diffuse the image, we add noise to the image a little bit, and then we ask the diffusion model to redo the noise. And when it denoises the image, you can see it has correctly been denoised, so like the yellow, the girl has yellow hairs. Here we have an example of adding a bird to a boy or changing the London layout. So yeah, it's working. The second thing is a control net. What is a control net? Control net will help you to guide the structure of the model. For example, I have a reference photo of a man, and he is standing like this. I can create an open pose of the reference photo, and then I can ask the model to generate the person that I need in the pose which I have set. There is a lot of different controlness. There is def-areas controlness, normal maps controlness, open pose, scribbles, like a lot of different ones. And the last one is an IP adapter. So how it's working? While the control net was focusing mostly on the structure of an image, the IP adapter is focusing mostly on the style of an image. Here is an example. Here is a woman driven as a sketch with a pencil. Yes? And here is a condition, the control net scribble. So like we add the control net condition and the style of an image, and at the end we are having the structure of the control net condition and the style of the IP adapter style condition. So here it is. You can see there is a lot of different types of how we can do this. Now about UI editors. For open source models, you need some open source UI editors. I'll tell you about two ones. The first one that you should go with is automatic 1111. So it looks like this, and it basically gives you all what you need to deploy the most basic pipelines. It's the most popular ones, and it also has a lot of plugins and widgets, so you can set it the right way very easily. The problem comes when you need to write more sophisticated pipeline. So like this is a simple pipeline. You have text encoding, generation, and upsampling. Upsampling is just having a bigger resolution of an image. Or like we can add control net or IP adapter as a guidance. But like the real production complex pipelines looks like this. And what we can see from this image. So like it really resembles a graph. It's a dark directed cycle graph. And I would love to have the graph interface to construct this type to construct this type of pipelines. And also, I have it. This is called ConfUI. It's a graph interface, and it has three main advancements. The first one is a graph one, so like it's very easy for you to build the graphs of the pipelines, of the very sophisticated pipelines. The second one has some caching. So for example, if you are changing only some stuff here, all of the stuff before don't need to be recomputed, because it doesn't change. So like this caching, it helps you to iterate much faster. Yeah. And the last one, it's very easy to write some plugins via Python to this interface. Okay, and in production, both automatic 1111 and ConfUI have APIs for production. Premature optimization is very valuable, so I do suggest you just to use those APIs, but if you want, you can use, I recommend the diffusion library from Hugging Face to write the inference. And one more thing. For example, you have a lovely dog, and you want to generate this dog on near Alps, near Fujiyama, in Bakeneko Palace, etc. So, what should you do? There is an option to train the model about the new object, so it would be able to generate this object consistently. What you really need? You need a set of your lovely dog. You train this model via the method called DreamBooth. You can use the Koya SS interface for it, and after some time, it will be able to generate you the images of a dog in a location that you want. Corgi. Okay. So now let's discuss videos. I'll tell you about these 4 options of how you can generate videos. There is a lot of them. like thousands of them. So like I'll just mention this four, but keep this in mind. So the first one is first order motion, and how it's working. Let's see. Okay, so how is this working? Basically, you provide an audio or a text file and an image, and it can animate an image to tell the text that was provided. This is the first type. This mainly could be used in UGCs, in TikTok, or like in other social networks. But the main disadvantage that you should keep in mind is that it doesn't allow you to have the dynamic background. So like it has some process, it has some process.
Do we in our world some tools for
when we integrate, we're actually just finding the area between the curve and the x-axis.
Sorry?
do we have real tools in current world to identify generated Vadims?
Okay, it's a very nice question. I think I would be able to answer it at the end of the conversation, because like it's too long to be answered. Okay, the next one is FameFlow. This is an old example. It's now much better, but here you can see the example. So here you can see one famous actor was de-aged. So what FameFlow basically does, you have a video of one actor and you want to change the face to another actor, or de-age the actor, or remove mustaches. Like there's a lot of different types. You can use this neural network for it. This method is very challenging because you still need the camera shoot. So like you need the full stage for shooting. And also, both actors need to resemble each other. The hairstyle should be resembled, the neck width should be resembled, and all other stuff should be resembled. The next one I would say is the stable diffusion based animations. So as you can see, it has also some advantages. Because like it's based on stable diffusion, you can have all guidance and all other stuff that stable diffusion gives you. But it also has some disadvantages. The main disadvantage is that the model, it is possible to generate an image, a video only for like for the length of like 5 seconds. Because like after 5 seconds the quality will drift. So like have process, have some concepts. And the last type is a sort of like video generation. This one is very hyped right now, and have a look at this.
Welcome to Beyond Our Reality, a journey in paradigm worlds where we delve into the extraordinary. Episode 1 unveils a giraffe flamingo, a stunning hybrid that roams the savannah with grace and vibrant hues. In episode 2, we descend into flying pigs, charming creatures that redefine the skies with their harmonious flavor. Episode 3 plunges us into the depths to discover the whale puss, an elegant blend of whale and octopus ruling the ocean's bliss. Episode 4 introduces us to the eel cat, an aquatic enigma that combines the sleekness of an eel with the curiosity of a cat. Episode 5 presents the bunny armadillo, a delightful mix of bunny charm and armadillo protection, captivating our hearts. Episode 6 features the horsefly, a small yet noble creature that buzzes with a blend of horse-like dignity and fly-like agility. Episode 7 explores the reptilian aru, a creature that leaps across the desert with the vigor of a kangaroo and the resilience of a reptile. Our adventure culminates in Episode 8 with the fox crow, a fusion of fox, cunning, and of freedom soaring through the forests of enigma. Join us on this mesmerizing journey through Beyond Our Reality, a journey through parallel worlds and the marvels of the unknown. Okay?
So as you can see, the quality is by magnitudes better. But, you can basically generate everything. They have their own, like this is the OpenAI's model. It consists of diffusion model and some the transformer that is possible to generate this type of stuff. But it's like this type of generation do really have some cons. The first cons is that there isn't a lot of noteworthy open source models to generate some stuff like this. And generating even very short videos could take a few hours. So like it's very compute inefficient. And due to heaviness of the training model and having an inference, like in the current scenario, I don't believe that in a year we will have an open source model for the video generation.
Welcome to Beyond Our Reality, a journey.
Okay, and now we are coming to tips. Just some basic tips that are open source from the internet that I do really love. So, like, this one is a little bit of hot take, so don't throw tomatoes at me, but like, I will explain it. So, like, when you're having a startup, you have some production baselines. So, like, you don't need really AI researchers and AI engineers. I do believe you need more the AI artists. So, why it is so? Basically, the AI engineers are more focused on the final average metric. So, like in average case scenario, the model would work averagely the best it can. But the AI artists are more focused on the quality of a final image. So, like, they understand when they should use the AI model, when they should use the Photoshop, and they are mostly like, as they are mostly aligned, the quality of the final image will be much better. The second takeaway is data is all you need. So, like, to train Dreambooth, you can train Dreambooth nicely with 25 images. But the idea is if you add like one or few images which are not the ideal ones, but if they have some problems, for example, it's a little bit blurry or a little bit overexposed, you could ruin your training. Even like with one or like with two images, the final image that will be created will be much ruined. The third one is an interesting encoder problem. So, like, here is an example. I told ChatGPT with DALL-E 3 generate image of a ramen, and this has generated an image of a ramen with an egg. And for example, I don't love eggs, and I wrote it again. Okay, generate the same but without eggs. And here is an image of bowl of freshly prepared ramen, this time without any eggs. You see the problem, yeah?
More eggs.
Yeah. Hate it. So, like, what is basically is going on here, or in the internals of the GPT? So, like, the GPT-4 understands my prompt and generates a query for a diffusional model. This is like a very big, sophisticated query. This query then interpreted by DALL-E text encoder, and then like this text encoder guides the final image generator model. And the problem here is that this DALL-E text encoder is very small and very, very stupid. So what's happened in the second case? The GPT-4 is smart and it has written a query. Okay, please generate like ramen, very beautiful ramen, but without text. And because DALL-E text encoder is very, very stupid, it cannot understand the negation. So it cannot understand the not. It just sees like the keyword X, and he stupidly just generates a lot of X, because like the X was mentioned in the prompt. You should keep this in mind when you are doing some prompts in the models like GPT-4 or like in some open source models, etc. The next thing that I would recommend you to remember is that the model is not the actual pipeline. So like you can have a lot of pre-processing and post-processing for the model. You can pre-process the query, as I have mentioned like in the previous slide, and also you can post-process to have some quality assurance. For example, isn't the image too blurry? Do we have the correct identity, etc. And also if your pipeline doesn't constrain to be real-time, sometimes it is just possible to open good old Photoshop and edit some things. Now I'll tell you a story. I gave my friend like last month an automatic 1111 interface. This guy does not understand how to generate images, and I told him just tweak some parameters to understand if the image, like which parameters are the most important for image generation. And after 2 hours, he told me I found the one parameter, the grail that will that is the most important one. And I told him, please show me the parameter, and he showed me the seed, the random seed of the generation. What we can take from this story? Basically, the quality of the final image generated by the diffusion models is very random. And sometimes it is much easier not to write the correct prompts, but to generate an image like 1,000 times with just different seed parameters. Okay, and the last slide will be about how to detect fakes. I would say like there are 2 clues. So the first one is that devil in the details. If you'll have a look at this image better, then we'll see that, for example, here there isn't a glass on the right glass of glass, and here like the cross is a little bit malformed, and also the cup, is it a cup? It's a little bit swirled. So like you should look at the details, and you will be
to like Pope never wears like this.
Yeah. And the second thing is a common sense. For example, in my opinion, the stainless, like this made of steel Eiffel Tower, it is not possible to be burnt like that. So like it's clearly a fake if you know a physics a little bit.
No way. Can you explain why for AI it's too hard to generate hands?
Okay, I have an opinion about this point. So basically, we as a person, we basically, when we are speaking with each other, we're basically looking at the eyes, at the face of a person, and at the hands of a person. So in my opinion, there is the same type of bugs, not only in the hands and not only in the eyes, like in the faces of a person, but also in different materials. Also, by the structure, the hands usually have very sophisticated like layouts, and like also our face have very sophisticated layouts. So it's just like it has much more details. So it's much harder to generate. In my opinion, if we'll generate an image of a pigeon, and this image of a pigeon would look okay for us, I do believe that if we'll show this image to a real pigeon, then he will be scared.
Okay, thank you.
Nice one.
Yeah,
Sure.
I just want to follow up on this one. So in case of Sora, there was some video and there was a discussion about the wheels of the car. There was a generated image when the car was moving. And for some reason, the Sora unfortunately wasn't able to recognize how to generate the moving wheel. So it can generate the wheel when it's still, but it can generate it when the wheel is moving. So, and the discussion was the following: that the only problem that we have is that there are no much context for the generating this image, and we will moving forward with this generation in with the hands of the human as well. When the model will have more understanding of the world. So currently we are trying, the diffusion model is simple generation without much context of the world. So how the physical processes are going, because the person can actually generate draw the moving wheel just because he understands how the physical processes are going on in the real world. So what do you think of this?
Yeah, okay, it's a very interesting question. And there is a beef right now between AI scientists, as I understand, in the AI industry right now, about all this stuff. Just to give you an example, in LLMs, like LLMs are having the top-down level approach. So like they kind of understand some data points of how the real world is working, and they can't interpolating, so finding something in the middle between like two known examples of how the world is working. And some scientists will think that they need to have also some bottom-up opinion, so like having some strong lemmas of how the world is working, and based on those lemmas you can construct like much harder lemmas, yada yada yada. So like, and the other side of scientists, they do think that like this top-down approach is good enough. So like we just need to give more and more data to models, and at the end they would understand all the quirks of how the world is working.
So yeah, no. So the last comment about this, that the next step when we will be able, for example, to have not only the video but also the information about the deepness inside the world. When we are looking through the two eyes, we can actually measure the how deeper is exact object. And seems like the next step, how to solve it actually, is to build a humanoid which will have the two eyes or the multiple cameras and will go through the world and collect the data and understands how to actually interact with the object and collect the information and understanding how the world actually works.
Yeah, it's one of the most prominent ideas right now, but like you should remember the Terminator.
Yeah. Agree fully.
Yes.
Which one?
All of them. Sir?
Yeah, I wanted to add about the question about the moving wheel. Like, what is a moving wheel in a picture? It's really hard to tell because you can have a picture which looks completely standstill while the car is moving 300 kilometers per hour. It's like all the matter of exposure and framing and how you do that. So you can actually have differently looking pictures of the same car going to the same speed. And the model doesn't have any idea. Do you want a picture that looks like a bit motion blurred, or the exposure is just enough so that the tire and the rim looks moving, or it's in the same position, like or it doesn't look standstill and stuff like that. And the model doesn't know anything about that. So you could probably ask for, like, make me a picture of car moving and motion blurred, and you get something that looks more like a moving car. Or you can just ask for a car, but it doesn't know these things, like you can have different exposures and stuff like that.
Exposure, diaphragm, and ISO, and other
And-
parameters.
yeah.
Are we there yet to generate something in live video feed?
Are we there yet to generate some in a live? Yeah. So like the deepfake technology is live, the first order motion is live, stable diffusion could be live. The Sora-like models are not capable to be live right now. They're too compute intensive. But like the deepfake technology is 100% to be live, and also the first one, the first order motion also is currently can be live. There is a open source GitHub repository called Deepface Live or Deepface Lab, as I remember, which gives you this live deepfake. But you should be aware that it is closed source, so
I meant like, because assuming a digital camera being the light feed, can you inject something inside or actually remove it?
Yeah, sure. You can change your face. You can style an image, but like you can use not generative computer vision algorithms, but discriminative computer vision algorithms like masks in Snapchat. So, guys, do you have questions?
Yeah, despite that moving view question is quite catchy, I want to ask you a more simple question. So, on the last Halloween, I tried to 3D print some custom decorations, and it was very simple, like spider sitting on a web in like wire art, like just black lines on white sheet. And for some reasons, I tried several models, and I spent 3 days and like 30 maybe bucks on this topic. Absolutely every model generated me spider with 7 legs, 10 legs, but never with 8 legs. Even if I specifically asked it to generate me a spider with 8 legs. Maybe you have some recommendations how to generate
Sure. So the question was how to generate 3D spider with 8, not 7 legs. Okay, so there is 2 points to answer. So the first thing, because of the generation of the diffusion model, is cannot really understand the context. So like one part of the diffusion models thinks that like the 8th leg has been generated. So like it does not generate the 8th leg. This is like the first thing. It is because like of some constraints of the diffusion models. And I have a happy news for you, because like 1 week ago there were 8 papers about generating 3D models with via diffusion or other generative AI models. And the result is prominent. I hope like that the 8th leg will be there. So like, new SOTA have 8 legs. And also about the wheels, I do believe that the main problem in the not in the diffusion part. The main problem is actually here in the text encoder part. So like in Sora-like and other videos, what you basically have, you have a text encoder which tells what to generate, and you have an image generator which generates this stuff. And this paper called Imagen, it has proven that it's like the main bottleneck right now in the generation is not in the diffusion itself, but in the text guidance. So like the text, the world model cannot understand fully what should be generated. So it cannot say to the image generator what should be generated.
So do you think that it's worth to generalize the message or go into opposite, like to make it very specific?
Sorry, could you repeat?
So if you are speaking about the text description of an image which I want to get, do you think that it's better to make it more detailed description?
No. Look, the problem here is even if you'll make them, the more detailed image description could actually help, but like the main problem is that this stuff is very stupid. And what we really need is to train the models which have the text encoder which is much smarter. But this is just much more harder by the compute resources.
It's not a problem to generate proper images, it's a problem to translate text to the image.
It's a problem of text to image translation. Exactly.
Yeah. You have the same problem with the text encoder. We had, I said, generate me a logo with text OK company in quotation marks. It's one of the 10. It's exactly the same text.
Yeah, it's also it's both like it's a spider's 8 leg problem and also like the stupid text encoder problem.
In quotation marks.
So
exactly the same text.
Okay, yeah. Here it is. Sorry, you were having a question.
Would it help to rephrase the prompt? So, for example, instead of result X, you write encoders, you change the result.
Okay, so the question is how to rephrase the prompt properly.
Will it help?
Yes, it will help. But like maybe the model doesn't understand what is eggless and like we'll say egg, and so it generates something with X.
And maybe you need to write 0 eggs.
No, it will also like the best thing that you can do in the DALI is just don't mention X. And the best thing that you can do in the stable diffusion models, you should add X to the negative prompt. Okay?